So I need to grab Jeff as well. See what's actually so we need to do this. Now we're fun. So so we need to go here. We're kind of skipping like the first part now. In this case. We're on module 2, if that's the case. Okay. Control lab. Okay. So we're just skipping the first one. We can just do the first one. It's fine. I don't really care for that right now, so it's okay. Just about thinking like an act. What? Zoom uses a virtual desktop to simulate real system. Press view site below. Fake bank application called fake bank launch when the loads. See banking application run browser. The bank show. I will find a after clicking view site, begin terminal. One of the common mistakes pages accessible to terminal. Right. Not typing it correctly. Okay. Oh, it's not a secure web. So I have images and bank transfer. We're probably gonna do bank transfers. Oh. Huh. What other? Oh, that was the other hidden image. Okay. Other website. Unify hidden panel. Add money to your site. Navigate to the admin panel. So you to add transfer because this is open. Technically, it will probably have authenticator, which it doesn't, which is weird. It will usually have auth, but there's so A81. So a shitload of money. That's easy. Okay, that wasn't that. Do I need to click this? Yeah. Can I change the name? Can I change the name? Can I not change it? And I should. Doesn't really matter. Anyway, so we do not care. Alt trace. Let's just go the full thing then, since the other one is. Let's go back. So back to dashboard. So we'll go to the actual thing that that is telling me to do. Wait, no. Oh, we're not. I was going to go to the network fundamentals, but I guess we're all of this first, I guess. It shouldn't take that long. Looking at the attack one, but we'll see. Census security. What is the main goal of? Can I just copy and paste this? Oh. Oh. Okay. So Joe is printed as SOC. Oh, first solo shift. I mean, he's monitoring dashboard up. Something doesn't look right. The real SOC analyst realize days. Cool. Open register, reviewed recent alert, identified source. Suspicious source. Attack. SQL injection. That was so weird. Fake. View the block the IP address. So add firewall. Adding this one to. It's not that easy, but we'll take it. We'll go through all of this just for the sake of it, because the ones that I really need is the network fundamentals, because I am a little bit hazy on it, but it's okay. So Residue has many paths, systems, defending a system specific. Yeah, yeah. Am I supposed to? Just gonna copy and paste it. I'm not sure why that's a part of the question test though on this task, but whatever. Security analyst often refers to digital defender as blue teams, people who monitor. So using the skills to investigate potential risk, known alerts to an example potential citizen in London office who settles in country, an investigation terminates legitimate. That typical day of security analysts and monitoring activity, investigating suspicious activity, seeing through information to understand what happened. How? Working with other teams to improve security. security. Defense? No. May not be in English. What? Wait. Security analysts play a significant role in stations. Okay. I'm just spelling correctly. If you enjoy problem solving and building things, high level security, system process. For example, responsible for maintaining infrastructure detection system, which can consider security cameras. Designing and maintaining security system, keeping up to date. Process. Security there is already specialized defense role. It's good. Pen tester. Curious human testing, ethical hacking, search to check security for weaknesses, exploits. All day, pen tester testing security, performing security assessment. That's in security policy. Offensive security specialized in application testing, similar full scale attack. Low key just jumping in it. Yo, these are questionable questions. Eating opponents. Low key, probably this one. Probably the last one. Yeah. We'll see what he gives us. Check the login. security. Now we'll just continue first. Do I need to? Oh, that was it. Okay. Cool. Am I done with this? Yeah. Okay. So we're actually at where we were supposed to be. That took 16 minutes. Okay, that's not that. We'll do is where I was supposed to be doing right now. So the heart's top. So we're basically only going until OC layers. I mean, we could probably finish the whole module. Low key, it's not that bad. We'll see. Oh, it's not playing though. Oh, wait, what would this be? Does that work? That's not work. Let's just keep.
Found in all walks of life. A city's public transportation system,
That's not even
the
showing.
London Tube, is a great example of this because it is a very well interconnected network, and it's a very big one too. Infrastructure such as the national power grid for electricity, another very important network. Meeting and greeting your neighbors, again, more of a safety network in that case. The postal system for sending letters and parcels, and so on and so forth. You can see networks everywhere in your life, and they're very, very important concepts. But more specifically, in computing, networking is the same idea, just dispersed to technological devices. Take your phone as an example. The reason that you have it is to access things, because if it didn't do anything, it'd be kind of like an old, I don't know, an old Palm Pilot or an old PDA, where, it's not that much good. It may be a calculator, disputing the claim that your teacher would say that you wouldn't have a calculator carried around in your pocket all the time. But you can see the importance of networks. We'll cover how these devices communicate with each other and the rules that follow. In computing, a network can be formed by anywhere from 2 devices to billions, so it doesn't really matter as long as it's more than, or 2 or more. These devices include everything from your laptop and phone to security cameras, traffic lights, and even farming. Networks are integrated into our everyday life.
Bro is just reading the actual lecture.
Weather, delivering
or
electricity
the
to homes,
the module.
determining
What?
who has the right way at a road. A right of way, rather. Because networks are so embedded in the modern day, networking is an essential concept to grasp in cybersecurity. Take the diagram below as an example. Alice, Bob, and Jim have formed their own network. We'll come onto this a bit later. We'll talk about this a little bit later on, so you can see just a basic network. Networks come in all shapes and sizes, which is something that we'll also come on to discuss throughout this module. Let's go ahead and dive into the question. What is the key term for devices that are connected together? That is a network. And there we go.
Wait, is he just giving the answers? Am I supposed to watch the video and actually get the answer, or am I supposed to answer that myself? Let's just answer that myself. Low key. Let's just go myself. I don't know. I don't think I'm supposed to just get the answer from here, because that wouldn't make sense, because he's actually giving the answers. I've thought of network system. Computing. Internet self using example. Let's mention that Alice made some new friends named Zane and Toby. She wants to introduce to Bob and Jim. Problem is that Alice is the only person who speaks the same language as Zane and Toby. So Alice will have to be the messenger. Because Alice can speak both languages, they can communicate to one another, forming a network. The first iteration of network internet was within the ARPANET. Fuck. It's been so long since I've seen this name. ARPANET project in the late 1960s. Oh my god, I remember the book that showed this picture, the picture of the ARPANET. It's like a huge ass thing. It was funded by United States Defense Department and was the first documented network in action. However, it wasn't until 1989 when the internet was slowly, we know it, was invented by Tim Berners-Lee by the creation of World Wide Web. It wasn't until the point that started for storing and sharing information, just like it's today. We're getting into topology and networking. I as previously stated, the internet is made up in small joined together. This small network is called private network, while it's called public network. The internet. So the recap. Devices will use a set of labels to identify which task who invented. I am sorry, but I am not gonna remember history regardless. To communicate in order, devices must be connected. Be both by IP addresses. Devices and network very similar to humans. Change our address and a MAC address. Address, internet protocol addresses can be used as ways of identifying hosts on the network for a period of time, where the IP address can be associated with another device without the IP address changing. First, let's put diagram below. For octet 255, is the whole thing. Typical piece 192.68. All goods want to go. It appears as a set of numbers divided by 4 octets. Yep. The value of the summarize. I hate the calculation, by the way, for this. Luckily, nowadays we have tools, right, for it. But the fact that you have to do math to actually count the IP addresses, I didn't like that. Yes, it's probably good that you know of it. But now there's so many ways you can just do this easier. Yeah. Appears well as the protocol. These protocols are backbone that we're going to force many devices to connect the same language, which is the same thing. However, we should recall the devices can be both on a private network and public network, depending on where they are. It will determine what the IP address, because there are ranges of IP, public and private IP. Most network nowadays is on a private IP address, unless you pay specifically for access to the public IP. But usually it's a double NAT situation where private IP, you're under private IP and one public IP, and you can't really port forward straight into the web unless, again, you pay for that specifically. But yeah, because we are running out of IP addresses. Public address is used to identify the device. Private addresses is used to identify other devices. 6 below. So as you can see, most private starts with 2, and public is here. So this is their public IP. It's private IP. But it's the same because this was the situation. So they're under the same network. This most day, like nowadays, this is even different house, or like different houses will have the same public IP address, unless you pay, and they will have the different subnet, a different IP address as well. Yeah. As more and more become connected, it's become larger to get because it's already in use. For example, Cisco, giant company network, estimated that approximately 50 billion devices connected to it by the end of 21. Enter IP address versions. Yep, we're currently, the main one we're using is IPv4, but we're trying to switch into a IPv6, which supports a lot more IP addresses. But not a lot of people, not a lot of things uses IPv6 yet. So yeah. Split into semicolons is separated, for example, following 6 characters. Vendor who built the network. Interface in this case is Intel unique identifier. However, interesting thing about MAC addresses can be faked and spoofed. Sent to another using MAC address. Security can also poorly implement the security design trustworthy thing. Yeah. There's cafe of tends often use MAC controller to use their guessing. So the configuration could wait. Oh, I can check this. Wait, how do you spell it? Am I tripping? Is it not offset? What's the question? What is each section IP address called? Am I tripping? Oh, I'm just doing it too fast. What? Deploy the interactive. Where is the button? Oh, there's a button there. Deploy the button and spoof your IP address to access the. What is the flag? So all I have to do is just basically change this to that. That will give me the answer. Yeah. This is one of the most fundamental tools that we get. It uses ICMP packet to determine the performance connection between devices. For example, if the connection exists or is it reliable. The time taken ICMP packets to travel between devices is measured by ping, such as the screenshot below. This measure is done by ICMP echo packet and ICMP echo replies from target device. Ping performance. Can I close this thing? Thank you. Ping can be performed against device on networks such as your home network or resources like website. This tool can easily installed on your OS such as Linux and Windows. The syntax to do simple ping is ping IP address or URL. See the screenshot below. This is in a Linux. Wait, no. This is. But this looks like Windows ping. I don't know. Here's the ping device. 2.1.254. The inferences now do the same thing. Deployable website is task. Okay. Is it already? Oh, it literally just doesn't let you type. Okay. Ping. Wait. ACMP. This was it? Oh, wait. Okay. What is this? Join the... Okay. I'm not even gonna bother with the video because I feel like the video is gonna... Oh. I don't really care. Regardless, I was about to say that the video is not necessary, but okay, it just blocks you regardless. So, over the years, there has been implementations of various network design in reference to topology. Yeah, star topology is right here. One device in the center, and then everything is connected to that device. Star topology. Main premises should be individually connected via the central networks such as switch or hub. Topology is most commonly found today because it's reliable and scalability despite the cost. And information sent to devices will be sent via the center control device to which it connects to. Let's explore some advantage of topology below. Because more cabling and the purchase of dedicated network equipment required for this topology, it's more expensive than any other topology. However, despite the added cost, the device this does provide some significant advantages. For example, this topology is much more scalable in nature. Add more devices, yeah. Fortunately, the more the network scales, the more maintenance, different cables, all of that stuff. Yeah, it's easier to fix, but it's annoying to fix as well. Because if something breaks, you only need to fix one line. But then again, I mean, I guess you don't really need to find that line. But then if you have it on a server, you'll have a shitload of cables, and you have to get rid of that one cable, and you have to do it. So it's a whole process. Bus topology. This relies on single connection, which known as the backbone. This type of topology is leaf. Mainly networking. ISP uses this. Because all data is travel the same cable is very prone to become slow, bottlenecked. However, instead, topology is one of the easiest, most efficient topology to set up because of their expenses, such as cabling and dedicated network. Lastly, another disadvantage of this topology is the little redundancy. Yeah, one thing breaks here, all of this thing breaks. Yeah. Ring topology, everything is connected. Everything. So connected to the loop. Which is guys will only send and receive data. If it does not have to send itself. There's only it's very troubleshoot. However, it's up short because it's in shit ways. Yeah, so you have to this first. So you have efficient than their lesser counterpart hubs or repeaters. So just keep track of the devices connected to which port. This way it's receive packets instead of repeating the package. Yeah, it's good. Have a network at home. You'll probably get an ISP router which have 2-3 ports. If you have a lot of computers at home that needs LAN, you might want to get switches. I mean, I guess if you're using Wi-Fi, you can get like repeaters and stuff, but you might want to connect the LAN into your switch, and then from the switch to whichever computer or however many. There are cheap ones that's like super good, and has like 6 ports. So that's a lot better than just using your main router connected, and it won't affect you as much. Ironically, I have one in my room right now, somewhere. But yes, I'm using a switch in this room, somewhere. Both switches rather can be connected to one another. The ability to increase the redundancy path data to connect. If one goes down, another can be used. Plus, it may reduce the overall performance of the network. Because packets takes longer to travel, there is no downtime, small price to pay, considering the alternative. Cool. Local area network. What? Am I simplifying that, or is that the actual answer? Device is used to essentially hub. Wait, no. Router. Wait. No, switch. such an yep. Mm-hmm. Huh. Lol. That's nice. Bruh. That's fun. Technically, if this breaks, it's kind of GG. Just break the center, bro. Yeah, that's literally what I just said. Technically, if you break that, it's GG. It's funny. I predicted the question. It's funny. Is it actually gonna stop me from doing anything else? No shot. Okay. I guess we stop at topology. Or yeah, because everything else is locked now. Um, so I guess that's it for now. I guess there's not much I can do other than this. It is telling me to do OC layers, which is like a couple down here. So I think that's why it's telling me to skip the first section, because it's technically not necessary. I can go for OC layer refreshment, but do I want to? 40 minutes. Technically, this is supposed to be like 90 minutes window, so a little bit longer. But it should be okay. I kind of do want to go through OC layers, but you really can't do anything here now. It kind of blocks you out. So that's kind of annoying. I will not go through the premium because it's not really necessary. Yeah, probably OC layer is the main one that I needed to go through, but it's okay for now, I guess. But yeah, I guess that's the. It's supposed to be like an hour. Let's see. It's supposed to be like an hour and no 90 minutes, an hour and 30. But I kind of went through a lot of them very quickly as well. So we're kind of locked in on this one. We're supposed to do the next module as well, but I guess that was it. I don't know. This was supposed to be just the study session that I have, so it's still 5:30. It's hella early. I guess that's it. Anyway, we will see you later if I do have anything. Might be playing something, but for now, we will end it there. It was supposed to be just this. But yeah,